One type of social research method to identify causal factors includes experiments. Experimental research has two key features, and those are manipulation and control. In terms of manipulation, researchers are able to manipulate exposure to an experimental treatment. That is, some type of exposure that the researcher believes affects a particular outcome. The other feature of experimental research is control, and by control, researchers are able to control for group differences by randomly assigning study participants into either a treatment or a comparison group. So the process of random assignment allows for researchers to control for extraneous variables and any group differences that might arise between the treatment and control group. So there's a manipulation of some type of treatment exposure, and there's a random assignment to an experimental group or a comparison group. Those are some of the key features of experimental research. Before we jump into the characteristics of experiments, one of the things that experiments allow the researcher to do is to make causal statements. If experimental results are statistically significant, it provides evidence of a causal relationship between some independent variable or treatment exposure X and some outcome variable or dependent variable Y. But in order to make causal statements, the researcher must establish three things. These include association, direction of influence, and the elimination of rival explanations. The first of these, association, refers to that X and Y co-vary together. That is, the treatment variable is related to the outcome variable. The independent variable is usually referred to as the treatment variable. The dependent variable is usually referred to as the outcome variable. And association means that these two factors are connected to one another, that X and Y tend to vary together. But association alone is not sufficient to make a causal statement. The researcher must also establish two other things. The second of these is the direction of influence. So the researcher needs to establish that X affects Y rather than vice versa. So the exposure, the treatment must occur before the outcome is observed. So the researcher sort of has to establish that the treatment exposure occurred prior in time to the outcome of interest, some sort of change that's observed in the study participant or some behavior or outcome has to sort of occur after the treatment exposure. So there has to be the researcher has to establish some kind of temporality, the direction of influence, that X affects Y rather than vice versa where Y affects X. So the direction of influence needs to be established. Third, the researcher has to eliminate rival explanations. So the researcher has to make sure that variables other than X did not cause Y. One explanation for any observed relationship between two variables, in this case independent variable X and dependent variable Y, might be that both variables are correlated with some third factor or variable Z. This is referred to as a spurious relationship. And so the researcher has to make sure that the influence of independent variable X on dependent variable Y remains even after controlling and accounting for variable Z that is associated with two factors. So one of my favorite examples is the case of chemotherapy and mortality. This is a really good example of the elimination of rival explanations. So if, say you are a hospital physician, you're working in a hospital, and you make an observation. You observe that many patients who receive chemotherapy have a high mortality rate. That is, the probability of mortality seems to be much higher among people who are receiving chemotherapy. As a researcher, you might, or as a person making observations, you might theorize that exposure to chemotherapy increases risk for mortality. But this might be, and you might establish a temporal relationship that the receipt of chemotherapy precedes mortality in time. So you've established an association, you've established a direction of influence, that temporal ordering in terms of variable X occurs before variable Y. However, you are not able to eliminate rival explanations because a third variable, cancer, or variable Z, accounts for the increased mortality that's observed among patients. So this third variable, Z, cancer, is associated with both receipt of chemotherapy and with increased mortality. So the observed association between chemotherapy and mortality is actually a spurious relationship that's actually attributable to cancer, variable Z. So there are two important things that a researcher must do when conducting experiments. The first is to establish internal validity, and this involves ensuring that there is sound experimental evidence that rules out extraneous factors, as in the prior experiment where a researcher was maybe trying to establish a relationship between chemotherapy and mortality, but was unable to rule out the extraneous factors that might account for that relationship, particularly the variable cancer. External validity is more about whether even if you have a great sound experiment, external validity is about whether the findings of your experiment can be generalized to other settings and populations, maybe outside of a laboratory environment. To establish internal validity, you must have sound experimental design. And sound experiments have to abide by certain criteria. And to establish a sound experimental design, the researcher should look at the requirements for what are called true experiments. True experiments have several characteristics. These include random assignment. So participants are assigned at random to either a treatment or a comparison group. There is manipulation of the treatment exposure variable or the independent variable. So the researcher is able to specifically manipulate which participants receive some type of treatment or exposure. And that's the independent variable X. The other characteristic of a true experiment is that the researcher measures the outcome of interest, the dependent variable. So in addition to sort of manipulating exposure to the treatment, the researcher is also measuring the outcome. And in many cases, they'll observe the outcome. They'll do a pre-test and a post-test. So they'll do measurements before and after study participants receive some type of treatment or exposure. Another characteristic of true experiments is that they include at least two study groups, an experimental group that receives the treatment or exposure, and an additional comparison or control group that is similar to the experimental group because people are randomly assigned to one or the other, but the comparison or control group does not receive the treatment or exposure. The final criteria for true experiments is the constancy of conditions across groups. So the researcher wants to make sure that everything is similar in terms of the characteristics, the environment, the setting between the experimental and comparison group. The only thing that is different between these two study groups is that the experimental group receives the treatment or exposure and the comparison or control group does not receive that treatment or exposure. That should be the only factor that distinguishes the two groups. Otherwise, you want constancy of conditions between the experimental and comparison groups. By establishing all of these characteristics, you're able if you follow to a T all of these criteria for true experiments, you'll be able to be confident that you have a sound experimental design. You'll have strong internal validity, that you followed the criteria of experiments. If you have statistically significant results for your experiment, you can be confident that changes in your independent variable, that exposure to that treatment, caused change in your dependent variable or the outcome of interest. Another interesting issue is more related to external validity. Many experiments are carried out in laboratories or under controlled conditions where accurate measurements are possible. A lot of psychology experiments are carried out in laboratories under controlled conditions, and this allows the researchers to very carefully manipulate a exposure to a treatment to collect measurements. Laboratory experiments are easy to replicate because they can be established within a setting, and they allow precise control over extraneous and independent variables. However, laboratory experiments can be a bit artificial. They don't necessarily reflect the real world environment. The alternative is like a field experiment where the researchers are actually carrying out experiments within a community or home-based setting or office setting in or kind of a real-world setting. And that's the alternative to a laboratory experiment. So related to this issue of laboratory experiments are establishing the external validity of experiments. That is, do the results of your experiment, can they be generalized to other settings or populations? And this comes up a lot in research, because a lot of experimental research is carried out at universities. It often is limited to populations of college students. So you can sort of think about our own case. If you conducted an experiment among students at Appalachian State, would those experimental findings, even if you had a true experiment with sound experimental design and statistically significant results, the question of whether your experimental findings would generalize to other residents in North Carolina outside of the college student population is a question of external validity. That is kind of the key issue, that the questions about whether the findings of an experiment generalize to other settings and populations.